Control space scaling. In this episode I wanted to have a look at some scaling issues that the rig at this moment still has before we continue with other parts of the arm rig. So if we, for example, set the arm space to be in the clavicle, the arm to be in the clavicle space, if we scale the main control, and we fixed the issues that were in the main control in an earlier episode, so this is still working. But if we, for example, now scale the chest control, you can see that there is some things going wrong. The clavicle length is getting longer, and the arm is also getting scaled, while the hand does not seem to be scaling in the correct way, because the control is here and the hand joint is not at the position of the IK control. So let's look at these issues now. So first we'll look at the clavicle, so we'll hide the arm so we can clearly see what's going on. So if we scale the control larger, the chest control, we can see that the clavicle control nicely scales with the chest control, and also the start position of the clavicle scales nicely, and the scale of the joints is also scaling. So only the length is a problem, and in this setup we want the clavicle to scale with the chest control because it's so closely in contact with the chest that you want the clavicle to scale the same as the chest. So if we look in the node editor in our clavicle setup, we can see that the length of the clavicle, so the distance of the end joint to the start joint, we are calculating with a local matrix in our setup, which is multiplied by the start matrix, so the matrix that's driving the start of the clavicle. And the local matrix only had the distance on the X set, so it is the distance from the start matrix towards the end. And the distance is getting scaled, and we fixed the scaling issue with the main control by calculating a matrix that was not scaled with the main control. So we had the matrix of the clavicle left control, for example, and we multiplied it with the inverse world matrix of the main input, so the main control where the scale of the main control was on. And that way we made sure that the matrices we are using were multiplied with the inverse world matrix of the main control, so the influence of the main control was undone, so to speak. So we're using the matrices as they were if the main control was not rotated, scaled, or positioned. So in the same way, we can use this to fix the scaling issue of the chest control, because we want to take the scaling of the chest control as well into account. We can simply replace the connections from the main input and connect them to the inverse world matrix of the parent input, and thereby we are calculating the length of the joint in a non-scaled version of the chest control, so to speak. So if we take the world inversion matrix of the parent input and plug it into the second port where the connection from the main input was going, you will see that the rig now breaks because we're using two different matrices for the no main scales. This one now has the inverse world matrix of the chest control, and this one still has the inverse world matrix of the main. So we're going to change this connection as well, connect it to the world inversion matrix of the parent input, connect it there. So now we can see that the joint is in the right position, and if we scale the chest control, the scale of the clavicle nicely moves along and still works in the same way as before and like it was intended. And if we use the lock length as well, we can lock it to the length of the base of the guide length. And if we now scale, it will stay in the scaled version of that length. So this way we have fixed the clavicle. And we'll reset the scale values for now. So now let's look at the arm. The arm has different spaces to work in that we created in another episode. So the scale for the of the parent of the arm is coming from different outputs of different modules depending on where this space is set to. So let's check them all. Let's start with the clavicle. In the clavicle we just fixed, and we have it's using the scale of the chest control. And if we now scale the chest control, we can see that the controls itself scale with the clavicle, only the arm segment length is not correctly scaling. So that's again because of the arm segment length that is calculated in the unscaled version. Just as with the clavicle, in the IK solver setup we created the no main scale world matrix nodes, where we have the upper base world matrix and the hand IK control world matrix, that it's multiplied by the in world inversion matrix of the main input node. So we have these world matrices in the space where the main control has not scaled, moved or translated, so we can calculate them in a unscaled variation. And we are using the world inversion matrix as well in the no main scale for the elbow IK lock control. So we can do the same thing as we did with the clavicle. We can take the parent input and take its world inversion matrix to calculate the no main scale matrices. So if we reconnect those connections, we can see that the scaling is now the same for the arm segments as for all the controls. But this is not exactly what we would expect if we were to scale the chest control, because now the whole arm is uniformly scaling with the chest, and we probably want to animate the chest scale without scaling the hand or the arm as a whole. So we have to set this up in another way. So let's undo this connection and still use the main scale, and then like so, and then let's set it up in such a way that if we scale the chest control, that the arm controls do not scale. So the arm rig will stay in the same global scale, but the chest control and the positions where the arm connect to will be scaled. So the arm still stays connected to the point of the chest where it is now connected to. So one way we could do this, if we look at the control setup, if we look at the guide of the clavicle output, which is this node that connects to the input of the left arm, the clavicle input, you can see that the connection is used in a few nodes. It is used in the upper base world matrix and as well in the clavicle space world matrix for the hand IK control, and it is used in the elbow IK clavicle space world matrix, as well as in the for the settings control, it's a world matrix. So what we could do if we didn't want to use the scale from the clavicle, you could say, all right, we can use a pick matrix, and if we take the offset parent matrix plug and plug it into the input matrix, and then we disable scale, let's disable shear as well, and if we now reroute these controls so that they connect to the output of the pick matrix, if we now scale the chest control, then you could say, all right, this is the exact behavior that we want, because the chest control is scaling and the arm is keeping its global scale. but the attachment is moving along with the chest. But because we disabled the scale or filtered out the scale from the matrix, we also filtered out the scale of the main control, because that scale is also flowing through the clavicle input. If we now scale the main control, we will see that the rig breaks because the controls of the arm and the whole arm rig does not scale with the main control. So this is not a viable option. So let's redo these connections and let's look at a way to set this up properly. Let's remove this one. So because the scale of the main control and the scale of the chest control are both incorporated in the matrix of the clavicle input, you will need to find a way to filter out the scale of the chest control without filtering out the scale of the main control. And there is one way we can do that. And if we create another blendMatrix node, like so, we can just simply multiply this matrix with the inverse world matrix of the main control, thereby disabling all transformations of the main control. So we are left with the main control at its default position and the chest control still scaled, rotated and translated in the way that it is. Then we can remove the scale from that matrix. So we just remove the scale from the chest control, and then again we can multiply it with the world matrix of the main control, thereby incorporating the transformations and the scale of the main control again in the matrix. So if we take the clavicle offset parent matrix, the clavicle from the clavicle input, plug it into the blendMatrix node, and if we then take the world inverse matrix of the arm main input, and the world inverse matrix, then we are left with the matrix that is basically the matrix of the chest control with the main control at its default position. Then we can take a big matrix, plug that in, and then we can disable the scale and the shear, so we're just left with the translate and rotate. And then we can make another blendMatrix node and then plug in the matrix of the big matrix and then multiply it again with the world matrix of the main input, so the offset parent matrix plug. And now the output of this matrix is the output of the clavicle without the scale of the chest control. So if we now were to take the outputs of the clavicle, these without this one, and reroute them to the output of this blendMatrix, we should have what we want. So let's do that. Like so. If we now scale the chest control, the arm is keeping its original scale and is moving along with the scaling of the chest control. And if we scale the main control, the arm is nicely scaling along with the main control, as well as with the orientation and translation of the main control and the orientation and translation of the chest as well. And of course, because it is in clavicle space, the clavicle rotation is also influencing the arm in such a way, but the scale still is not influencing the arm rig. So this way we have devised the matrix without the chest scale but with the main scale. So let's rename these nodes really quick. So I renamed the nodes the clavicle input no main X-form matrix. X-form is also another word for transformation matrix, so the X-form matrix. And then the clavicle input no scale matrix, where we filter out the scale and shear. And then the clavicle input world matrix, where we apply the transformations of the main control. And there is still one thing that we should or could have a look at. Because we have given the modules the option where the arm, the start of the arm is not necessarily at the same position of the end of the clavicle, we can set the position of the arm to start anywhere with a certain offset. You might or could think that if you scale the chest, including the clavicle, that the distance of the offset should shrink with the chest control. This is a preference. Probably in some cases the arm would start at such a close distance to the clavicle end that it doesn't really matter. But just for the learning purpose, we will look at a way to scale the offset as well, while still maintaining the function of the rig as we have it right now. So let's take a look. So if we look at where the offset is calculated, we are using the guide or the oriented guide of the upper arm multiplied with the inverser of the clavicle out guide to calculate the offset matrix, and that matrix is multiplied with the output of the clavicle to generate the start point of the arm. So if we follow the connections of the newly generated clavicle output, we will probably end up here with the upper base world matrix, which is the start point of the arm. If we create a temporary locator and remove the shape, take the matrix and plug it into the offset parent matrix, you can see this is the start matrix of the arm, and we are using the, let's see, the oriented FK guide matrix. So that is the start of the matrix that is oriented in such a way that the y-axis is pointing backwards and the x-axis is pointing towards the hand in this case, I guess. No, the lower, to the elbow. It's pointing towards the elbow. Yeah, because it's the FK. And we are multiplying it with the inverted world matrix of the clavicle guide. So, but because we now have changed the matrix to have not the scale of the upper or the chest and the clavicle, we are multiplying the offset with the matrix without the scale. So if we were to change this back, so if we would not use the matrix that has not the scale of the chest, but not this one, that one, plug it back into the clavicle input matrix, like so. Then if we scale the chest, we can see that the distance is scaling with it. So this is exactly what we would want. So if we were to exaggerate the offset, like so, for example, have the arm start here, and then if we scale down the chest, you will see that the distance gets proportionally less when we scale the chest. So this is the correct way to scale the distance, but now we have the same problem because we omitted the removing of the scale of the chest for the rest of the arm. So now the FK controls are again scaling with the chest control, what we didn't want. So what we now need to do is apply this trick of removing the scale of the parent only after the point where we created this world matrix start of the arm. So after the upper base world matrix. So if we now do the same thing here, so let's create a world matrix node and plug in the output matrix and then multiply it with the inverser world matrix of the main input, like so. And then we create a big matrix and plug the output in, disable the scale in the share, and then create another multi-matrix node. And we take the output of the big matrix, plug it in the first input, and then we take the world matrix of the main again to multiply just as we did here. We take the offset parent matrix of the main input and plug it into the second port of the multi-matrix node. Now we have generated the same matrix without the scale of its parent, so without the scale of the chest in this case. So we can take the outputs of this node and reroute them to the output of the blendMatrix node, like so. And now we should have fixed the issue where the arm is scaling, and we clearly can see that that did not fix it. So we you can see that the controls have now the correct scaling, but the segment lengths are still off. So we have to correct the segment lengths in the same way as well. So let's set the scale to 1 again. And you will probably see if we take we took all the outputs of the base blendMatrix and rerouted them to the end of the new blendMatrix, but not all the connections to the base blendMatrix are in this node graph. As you will see in the IK solver tab we have used this one as well. So, and this is used for the calculation of the length by this node, and as well later on here for the ball vector IK position. Let's see the vector of the that is used as in the IK solver. So to orient the solved IK or to orient it in the right rotation plane and aim it to the hand. So we can update these connections as well. So we should take the output that we just created, add it to this panel as well, and then we can take the outputs of the upper base blendMatrix and plug that into the output of the newly created blendMatrix node, and now we will probably not have the same issue anymore. So this is correct, it's now working, but then again you will see if we scale the arm up, you can see that the arm is bending. This is not wrong. This is just because we are scaling up the offset of the start of the arm relative to the clavicle, but the position of the hand, which is also has now the space of the clavicle, it is not has not the same increased offset relative to the end of the clavicle. So the hand has the same offset compared to the guide of the clavicle end, but the start of the arm has an increased distance. So the arm gets bent. So if we wanted to prevent this from happening, we have to calculate the offsets of the hand not relative to the end of the clavicle, but to the start of the arm. So if we reset the chest control, we can set that up as well in the other node panel. Maybe let's first rename these nodes. So using the same logic, I'll rename them off screen. So I renamed them to be upper base no main X-form blendMatrix, and then the pick matrix is called base no parent scale blendMatrix, and the blendMatrix where we reapply the matrix of the main control I have called base main transform or main X-form blendMatrix. So let's look at how to set up the correct way to compensate for the offset. So if we look at it very simple, to make the point more clear, if we look at the distances, because the distance from the hand to the end of the clavicle, let's say here, is still the same length as it was in the unscaled version, but the distance from the end of the clavicle to the start of the arm has grown. So if this would not have been scaled, it would still have been somewhere around here, and the arm would still have been straight, because the distance of the arm would not have changed. But now the distance of the arm has changed, so now it is bending because it is not anymore in its rest length. So let's remove the blue pencil again, and let's fix this. So if we first take a look at the hand control, if we find it in our control node editor tab, you can see that's the world matrix is coming from the space switching node, the parent matrix node, and then because we are in the default space or the clavicle space, it is using this matrix, and the parent offset or the buffer matrix is calculated from the oriented hand guide, so the hand guide world matrix of the with the correct orientation, so in the rotation plane of the arm, and it is multiplied by the inverser world matrix that is coming from the clavicle guide input. So we are calculating the buffer from the output of the end of the clavicle to the guide of the hand. But now the start of the arm is changing depending on the scale of the chest. So what we could do to solve this is to not calculate the buffer of the hand relative to the output of the clavicle, but relative to the start of the arm, which is moving or changing position when the chest is scaling. So we could take the not take the world inversion matrix of the clavicle guide to calculate the buffer matrix or offset matrix, but take the world inversion matrix of the start or guide of the start guide of the arm. So if we look at the where we were, let's track back the hand. So here, this offset or buffer matrix. We now have to change this connection to the inversion world matrix of the oriented guide that is the start of the arm. So that is the upper, let's see where it is, and I think it's this one, the upper FK guide outworld matrix. If we create a locator, remove the shape, and we look at the matrix, we can see that this is the matrix that is at the start of the arm, and it's pointing towards the elbow with the X direction, and the Y direction is nicely oriented towards the rotation plane of the arm. So if we were to change the guide, upper guide, the rotation, you can see that the orientation plane, the rotation plane of the arm is changing, and as well our locator is also changing to the same orientation. So let's undo the rotation. So this is the matrix, the oriented guide matrix that we want to have the inverse of, so we can calculate the offset matrix relative to this matrix. So the offset matrix of the hand relative to the start of the arm, so that we can after that multiply the offset matrix with the shifted or scaled position matrix of the start of the arm, so that the arm moves as a whole with the offset of the start of the arm relative to the clavicle also scaling. So let's create the inverser world matrix by making an inversion matrix node, and we take the output and plug it in to the input matrix, and let's call it the world inverser world matrix. I think we already have this one because Maya puts a 1 behind it. So let's find the node, see where it is. It is already here. We have already created it, so we can just delete it and reuse this one. So that's nice. So let's see, where were we? The hand IK parent offset matrix, so this one. So we can take the upper FK guide outworld matrix inverser, and then we can plug it into the hand IK control parent offset matrix or the buffer matrix, and now you will see that the arm rig changes to a wrong state because we're now calculating the buffer relative to the oriented start of the arm, but we're not multiplying it by the oriented correctly oriented matrix of the start of the arm, because this is where we do that. So we are now taking the clavicle input world matrix, where we disabled the scale of the chest, but we now need to take the output of the start of the arm that we just created with the same nodes. Yes, this one. So this is the matrix that we created that is at the start of the arm, that has the scaled position offset relative to the clavicle and has the right orientation, but does not have the scale of the chest, and only the scale of the main control. So if we now take the output of this and plug it into our hand IK clavicle space world matrix, you will see that the arm now is in its correct position again. And if we now scale the chest, you will see that the arm is no longer bending, the offset relative to the clavicle is nicely scaling, and the arm is staying in its correct position as well. It is still rotating with the chest as well as with the clavicle. So now we have this correct. So to summarize, we have now created the offset matrix of the hand to be relative to the start of the arm, and the start of the arm position is scaled, the offset is scaled with the chest scaling, but the scaling of the chest is after the offset is scaled is removed with the mult matrix and pick matrix nodes, and therefore only the scale of the main control remains. So this is also still working correctly. So let's reset the scaling like so. And this one is default, and this one is as well. But now we have two places where we remove the scale of the parent. So we have it after the clavicle input, these nodes, and we as well have it after the upper base world matrix. So can we not just use this one for all of them? The short answer is yes, we can, because if we look at the other three, so the ones we set up earlier, if we look at the outputs that are using this output, it is used in the elbow IK clavicle space world matrix, which uses the offset parent offset matrix or the buffer matrix that is also using the clavicle guide inverse world matrix. So we can just do the same thing with the as we did with the hand IK. We can swap this plug for the world inversion matrix of the oriented guide. So the one that was, let's see here, this one. And then we can take the output of the world matrix, where we remove the scale of the parent, to be the driver. And the same thing goes for the other output of this one, which is going to the settings control. Its buffer and matrix calculation is also using the world inversion matrix of the clavicle guide input, so we can swap those connections as well. So let's do that. So first, let's do it for the settings control. So we want to change the world inversion matrix of the clavicle guide input for the world inversion matrix of the oriented start matrix of the arm, which was, let's see, let's track it down again. So we have the offset matrix, oops, it's using this upper FK guide out world inversion matrix. So maybe we should rename these to not use the FK space, because we are also using it for the IK and others, but let's fix this in a minute. So first take this plug and go to the settings control parent offset matrix or buffer matrix, offset matrix, however you want to call it, plug it into the second port. Then the settings control shifts off its position because we're still using the driving matrix of the output of the clavicle, namely the one that we removed the scaling of the chest control of. So if we want to replace this control or this connection with the oriented matrix or the driver matrix of the start of the arm, we have to take the one up here, also where we removed, so the base matrix, where we removed the scale of the chest control. So we take this output and plug it into the second part of this one, and now you'll see it's back to its correct position, and as well it is still working as intended. And we can do the same thing for the other connection that's coming from here. So that is for the elbow IK control buffer matrix or offset matrix calculation. So the second plug is going to the world inversion matrix of the clavicle guide input. So again, we can take track it back, the world inversion matrix of the FK guide, so the oriented FK guide matrix, but it's inverser. And let's see, where were we? Right here. So this one. So now it is using the start of the arm, and then again we have to change the driving connection from the clavicle input world matrix that we created before and change it to the connection of the base world matrix. So let's take that one and plug it in here. So now we are back again, and we can remove these nodes because they now do not have a connection anymore. So let's remove them. And now you can see that only the clavicle input world matrix is only used by the calculation of the base world matrix, which then has the 3 nodes we just created to remove the scaling of the chest control, the parent control. So we're now using this matrix to drive all the other controls by multiplying the calculated buffer matrices with this matrix. So then we should rename the control. Let's see, this one, because it's not only used by the FK anymore. So let's maybe call this the upper guide outworld matrix, and then this one is also not only for FK but for both IK and FK. So let's rename it like this, so it's more clear what is. So we can remove the temporary locators that we created. That's the only one, I think. And maybe space this out a little bit better, so it is clear again what we have done. And then we are back in business, so to speak. So now we have corrected the chest space with the correct scaling as we wanted it. So all the translation and rotation are coming from the clavicle, but the scaling is only coming from the main control. But that's only for the clavicle space, so we have to do the same thing for the other spaces. So the chest space, for example, if we now change the chest space, you can see that the same thing is happening because the hand IK control is still scaling with the chest control. So we have to disconnect that so that the position is only changed relative to the start of the arm, but the scale of the hand control is not influenced by the scale of the chest control. So if we look at where the scaling is coming from, they are coming from the inputs of this arm module. So if we go to the chest space, So we have them here, the chest input and the chest guide. So we have to do the same thing. The chest input world matrix or offset parent matrix also has the scaling of the world matrix and the scaling of the chest matrix baked into it. So we have to remove the scaling of the chest matrix in the same way as we did before by multiplying the inverser by the inversion matrix of the main control, then removing the scaling and share with the big matrix, and then multiplying again with the world matrix of the main control, and thereby only having the main scale remaining in the matrix. So let's do the same thing. Let's create a blendMatrix node, and let's plug in the matrix, and then refresh the inputs by pressing 1 and 3. And then we multiply it by the inverser world matrix of the main input. So we take this one and plug it in here. And then we create another big matrix node. And we plug the output of the blendMatrix node in it. Then we disable the scale and the share. And then we create another blendMatrix node. And now we take the output of the big matrix and plug it into the first plug, and then we take the offset parent matrix of the main input and we multiply it again, and thereby ending up with the same thing as before, the chest input matrix without the scaling of the chest matrix, chest control, but with the scaling of the main control. And if we now take the outputs of the chest input and reroute them to the outputs of this blendMatrix node, like so, then we should have fixed our problem. And indeed, we have now correct scaling on the FK of the arm, and the hand IK control is staying in place, which is well, what we want, because the position of the chest is not changing, but the rotation of the chest is influencing the hand control, and the position of the chest control is also influencing the hand IK control, only the scaling is not. And in this instance you end up with stretching and bending of the arm, but this is kind of implicit to the way this is set up, because we are calculating the offset of the hand relative to the chest control, but the start of the arm, as you can see, is scaling with the chest control. So if we wanted to have the arm not stretch and bend, we have to do the same thing as we did with the clavicle and make this offset as well relative to the start of the arm. But let's first rename these nodes really quickly. So I renamed these nodes to the chest input no main XForm world matrix, and the big matrix to the chest input no parent scale world matrix, and then the last world matrix node to the chest input world matrix. So the world matrix of the chest without the scaling of the chest and only the scaling of the main control. And we're going to leave this as is, because when you have the hands in the chest space, you probably want the position to stay the same when you scale the chest, and only follow the rotation and translation like this. But if you wanted to do the same thing as with the clavicle, you could, where you have the offset of the hand IK, the buffer matrix, so to speak, calculated relative to the start of the arm, where the start of the arm then has to be calculated relative to the clavicle, but in the orientation of the chest, because you don't want the rotation of the clavicle to be taken into account when you are in chest space. But we're going to leave that for now like this, so we can proceed to the hip space for the arm. So when we switch the arm to the hip space, we will see the same errors behavior. If we scale the hip, that the hand IK control is scaling down with the hip control. We don't want that. We do want to have its rotation and position locked to the hip control, but not the scale, because that wouldn't make any sense. So let's do the same thing as with the chest. If we look at where the hip matrix is coming from, that's from the hip input. So in the node editor, it's these two nodes. It's the hip input and the hip guide input, where the offset parent matrix of the hip input is the driving matrix. So we need to remove the scale from the hip and leave the scale of the main control from this output plug. So we can do the same thing. We create another blendMatrix node. We plug in the matrix and refresh the inputs, and then we take the inverse blendMatrix of the main input and we plug it in the second port. Then we create a pick matrix and we plug in the output to the input matrix, and then we disable the scale and share again, and we create another blendMatrix node where we plug the output of the pick matrix into the first plug, and then we take the blendMatrix of the main input, so the offset parent matrix plug, and plug it into the second port. And now we have created the matrix without the scaling of the hip control itself. So let's take the outputs and reroute them to the blendMatrix node. Like so. And now if we scale the hip control, you can see that the scaling does not influence the hand, but the rotation and the translation still has the effect that we want to have when switching the space of the hand IK control to the hip control. So let's rename these nodes as well. So I've renamed them again to the hip input no main X form blendMatrix, the hip input no parent scale blendMatrix, and the hip input blendMatrix. And that is the hip space scaling fixed. And then we can continue to the main scale. So the main scale, if we scale the main control, the hand is still correct because the main scaling was already incorporated, and it's the only scale that is using the hand IK control right now. So for the main scale, we do not have to fix anything because it was already working. So there's one space left, and that is the world space. And if we scale the rig right now, and because the hand is in world space, well, the scaling of the hand is not affected, but the whole rig is affected when we scale the main control. So this space is kind of a weird one, and this is why I usually do not set this up this way. Instead of using a world space, I use another control in the root module, a master control, so to speak, where the master control is determining the overall scaling and maybe the basic position of orientation of the character, and then the main scale can still be used inside of that for motion or whatever. And then the scaling of the master control can drive the position of the hand control. So let's switch to that setup. And then we can rename this to be master, for example. So let's first add another control to our root module. So if we go to the root, we do not have it here anymore. So let's graph it, and we can remove the make nerve circle for this. And we can duplicate the main control, and let's call it master control. Let's make it for now, let's just make it a little bit bigger so we can see it. And then the main control now directly outputs into the main output, and the main guide is used directly into the main control. So we have to use the guide to feed into the master control, and then the master control should drive the main control. And because the main control and the master control should always be in the same position, we do not need any buffer or offset matrices being calculated between these two controls. So we can just take the main guide and plug it directly into the offset parent matrix of the master control, and then we can take the master control world matrix and plug it directly into the main control offset parent matrix, like so. So we have now introduced the master control in between. So the master control, of course, now scales the whole rig as well, and the main control translates within. And now we should disable the scaling of the main control, because now the master control is the source of the global scaling of the rig. So let's take this and disable the scaling. So we lock and hide this, and on the master control we keep it like so. So at this point it becomes more apparent why you would only want to scale your rig uniformly, because if you now, for example, would scale the main control or the master control only in the x-axis, and then, for example, if you would rotate the main control like so, then the rig would get skewed, and well, this doesn't make any sense anymore. So for this reason, most rigs only have uniform scaling enabled, so we can do that as well. So if we take the master control, we can just take, we can create a benign cycle loop. So for example, take the Y scale and plug it into the X scale directly, and as well into the Z scale. So now we have a cycle loop on this node, but it doesn't really matter because it's just one node. So Maya will evaluate this node the same way, and just when it needs the scale X, it just evaluates the scale Y first, and then the scaling is uniform. So we can lock these as well. You could also hide them, but now you have scaling as well, which is only uniformly. And if you now scale the rig and rotate the main control, it doesn't matter because the scaling is uniform, and everything gets keeps the same matrix without skewing. So let's reset this value and maybe just hide them as well, like so. And then we have our uniform scaling set up. And now we need to rename the space. So if we go back to the main, you can still see, of course we cannot scale the main anymore, but the rotation and translation is still working, and the scaling is also still working, like so. And if we now change the space, so we go to the attribute and we go to edit attribute, and we go to the space, we can select the world space and we rename it to be master. Yep, like so. And then we see that it's now master space, and then we can use this as an input to the ARM rig for the for this space. So let's create the output for this as well. So in the root outputs, and let's create another output. We do not really need a guide for the master because it's basically the same. So you could do it for the sake of, well, completeness, but for now I'm going to leave it out. So the master output, and then we take the world matrix of the master control and plug it into the offset parent matrix of the output. So we have that as well. And then in the control setup node graph, we can add the, let's say it's here, add the master output, and then in the ARM we can create a master input as well. So let's just duplicate this one and rename it to be master input. And then we take, we put it up here somewhere. Maybe we can move these down. Yeah, it doesn't really matter. Maybe there was a logic to go from the highest to the lowest. So in that case, you would say, okay, hip would be first, and then chest, and then clavicle last. But the order doesn't really matter. So let's take the newly created master input, and we take the output of the root master output, take the offset parent matrix plug, and we plug it into the offset parent matrix plug of the left master input, like so. And then we can use this as the basis for the space, the master space of the arm. So it is a master space. So if we go to the IK control, here we have the last space being the master, which only had the offset matrix being directly the hand guide, because it was the offset relative to the world origin. But now we are not going to use that as an offset again anymore, because we are now going to use the master control, which can be at a different space. So we have to calculate the offset just like with the other spaces. So we need to create a blendMatrix node, and we take, just as with the other offset matrices, we take the output from the oriented hand guide, the outward matrix. We plug that in the first port, and then we take the inverse world matrix of the parent space guide. So in this case, it is the same guide as the main control, because the master and the main control are using the same guide position. So we take the main guide world inversion matrix. So if you want to have real clear readability in your rig, you might as well create the master guide output, but that would be extra nodes with the same function. So for now, I'll take less nodes over readability. So we take that and plug it into the second port, and then we have our master space offset matrix. So master space parent offset matrix, and then we use this as the offset matrix in our master space, and now we have to use the target matrix, which is the matrix, the output matrix of the master input node. So if we take the offset parent matrix plug and we take that into the target matrix, then you'll see that the hand nicely moves back to its correct position. And now if we set it to master space, which we already had, and we move the main control, you will see that the hand stays in its correct position. If we rotate it as well, but if we use the master control, then the whole rig moves along with it, which makes more sense than leaving the hand control in absolute world space without any means to modify its position. So now we have incorporated that master control as the new world space for this hand control. And we need to do the same thing for the other IK controls. So we did it for the hand, and let's check the elbow as well. We are using the, let's see, the same, the oriented plane guide as the offset matrix. But again, we have to recalculate the offset matrix with a blendMatrix node. So let's create a blendMatrix node. Let's take the same basis. So the oriented plane guide. because again it is now not relative to the world origin anymore, but relative to the master control. So we should create the correct offset matrix, and then we take the the main guide inverse world matrix again. So if we look at this, you will probably see that if we take this plug, which I'm now realizing as well, these nodes are basically exactly using the same plugs. So we're creating a duplicate because the master and the main control use the same guide. The offset matrices are also the same, so we could in fact just reuse this to as the offset matrix as well, like so, and we can delete this, and then we can use the master offset parent matrix, the master input, as the target, like so. And then for the IK control, it is working correctly as well. So, and we can do the same thing with this, because this master space is as well exactly using the same connections. So we can remove that one and reuse this node as well, like so. So remove this as well. And lastly, we should do the same thing for the space switching of the FK controls, and thereby fixing the orientation of the IK elbow control as well. So looking at the third target, we are now using the upper guide outward matrix directly as the offset, and again with the same reasoning as the other two space switches, we can reuse the main space parent offset matrix or buffer matrix, because it is using the oriented upper guide and the world inversion matrix of the main guide, which is the same as the master guide. So we can reuse that. So let's plug this one into here as well, and then we should use the master output or input parent offset matrix for the target matrix. So let's take this one, the master input offset parent matrix, and plug it into the target matrix. And now if we rotate the main control, the orientation of the elbow is still rotating. So let's see what is happening there. Is the FK working correctly? Let's see. Use FK. The FK is still rotating as well. So let's check what's going wrong. So after some quick digging, I found the issue, and this happens to me a lot as well. So it's well handy for you to know as well. The node after the space switch node for the upper FK control, it's a blendMatrix node. If you have a blendMatrix node with a target and you have the weight value set to specific values, as soon as you disconnect or reconnect the connection, Maya resets all the weights to the default values, because when the connection is or the plug is reconnected to another node, Maya first disconnects the node, and then if all the input plugs of the target are disconnected, Maya removes the targets. So it deletes the item, the target item of the array, and then the plug is reconnected. Then it creates a new item in the array with all the default values and the connection made to it. So it resets all the values. And for the upper FK control world matrix, we only had this blendMatrix because we wanted the position to stay at the end of the clavicle and not at the position driven by the other spaces. So we have to set the scale, the rotate, and the shear to 0, and only leave the translation to 1. And, then it is fixed for the FK arm. So you can see the FK arm is now staying oriented to the master control, and if we now rotate the master control, it is rotating along, and as well the clavicle rotation is not influencing the rotation of the FK arm, but the position is. So let's reset all these values. Like so. And as you can see, the same thing is happening with the IK elbow control. If we look at the IK elbow control here in the blendMatrix, you can see that the plug of the first target, which is the as well the base main X-form world matrix, which we used for the position blending of the upper FK. We want to do the same thing for the FK control, because we want to set the position to there and then blend the position to halfway between the hand IK control and the start of the arm. And in this node as well, probably the connection was updated when we renamed the node or added the nodes in between, because if you remember, we created this node to remove the scaling, and thereby reconnecting all the plugs. So all the plugs of the output that were going to blendMatrix nodes, the values were reset, and it is going to this node as well, and thereby all the values were reset to the default values. So it's kind of annoying. It's something you have to keep in mind when changing connections that go to a blendMatrix node. You could, to prevent this, create an extra node which is set to 1 that you connect to the weight, because then there will always be a connection to the target, and then it will not be removed when you remove the target matrix plug. It's kind of annoying, but you'll run into it eventually. So to fix this, we need to just remove the rotation, scale, and share from the blendMatrix target, and then we have the correct orientation for the elbow control as well. And while we're at it, let's check all the other connections. So we fixed this one, which was a blendMatrix node. We fixed this one, which was a blendMatrix node, and it's going down here, which is just a multmatrix node. That doesn't change. This one neither, and this one also multmatrix. So the other ones are fine. And while we're at it, we can check these, because we updated these connections as well. These are going to a parent matrix, which is fine, and another parent matrix, which is fine, and here as well a parent matrix node. So these are fine, and the same goes for this one. It's also going to a parent matrix, a parent matrix, a parent matrix, and a multimatrix. So these are all fine. So this is something you have to keep in mind with the blendMatrix nodes. It can be kind of annoying, especially when you don't remember the exact settings that you put in. But with some tinkering, you'll figure them out again, probably. So now we have this fixed. So the master control rotates and scales everything nicely, and the main control just rotates and translates. And as long as the space switch for the arm is set to be master, the rotation of the main control only repositions the arm, and the orientation stays the same. So we can move this back to IK, and as you could see as well, when we were in FK mode, the arm segments were too long, but this is only the preview mesh. You can see that the joints are in the correct position, and we are driving these arms with a connection. I don't know if we still have this set up somewhere. Probably not. So let's add them both so we can fix this while we're at it. It's not very necessary for the rig, because we're not going to use these. They're just temporary preview nodes, but just for the completeness we can maybe fix these as well. let's see. So we're driving the scale of the previsualization meshes with the output of the elbow lock length switch, which is only used in the IK setup. So logically the length of the IK is now used for the preview meshes. So if we want to have the FK length correctly, we have to build a switch just for the preview meshes. So maybe we'll just leave it like it is, because the rig is functioning correctly. It's just the length of the preview meshes that are off. So maybe just ignore it for now and don't spend any notes on it, because we're going to leave it in the end anyway. So let's just reset this value and ignore the wrong scaling of the preview meshes in the FK mode. So then we can reset this to a default value, or maybe master is a logical default. And then we have fixed all our scaling issues with the spaces, and we have a stable rig state again. There is one last thing we have to fix though, because we added a space switch to the elbow locker as well, and that one is still referring to the world. And sure enough, when we put it to world and we enable the lock, and of course set the IK switch to IK, and then now if we scale the master control, it is not scaling along with the master control, and it's also not moving along with the master control. So we have to fix that space still, in the same way we did for the hand IK control. So if we look at the elbow locker, we can see that, let's see, it's space switching node. So the parent matrix node is again using the let's see, the offset matrix for the world space, because the target 1 is the third space, because the input is the first and the target 0 is the second and the target 1 is the third space. So that's the world. It is taking the offset matrix of the elbow locker guide, because it used to be absolute world space, so the guide was the offset matrix or the buffer matrix relative to the world origin. So we now have to calculate the offset again, but the same with the other spaces. The world space, let's see, the offset matrix of the world space, this one, is using the elbow locker and the inverse world matrix of the main guide, which is the same as the master guide. So we can just reuse this node. So the main space parent offset matrix or buffer matrix we can use as the offset matrix of the world space, and then again we can use the master input matrix as the target matrix. So let's take that one. So the master, let's say, offset parent matrix, and then we plug that into the target matrix. And now if we move and we rotate and we scale the master control, the elbow locker nicely moves along. So now we have fixed that one as well. And if we, for example, move away and rotate the main control, and we now switch the space of the elbow locker to be main, then it is moving along with the main control. And of course, if we move the arm space to main as well, the hand is also moving in the main control space. So that all works. So let's reset all the control values. Let's reset this to use the master space, and let's disable the locker and keep this in world space. Let's rename this. So edit attributes, and in the space let's change this to master as well, like so. All right, and then now we have finished and we can move on to the next episode.